Before we can actually go on to introduce the idea of a Riemann sum, there's a few things that we need to cover first. The most important is sigma notation, because Riemann sums are actually based on the idea of the sigma notation. Now this Greek letter here looks like a capital E, it's kind of a square boxy looking thing, is actually the Greek letter sigma. And when we use it in this form, I have sigma I equals 1 to n of ai. Well, what this means is I'm going to add up all the a's from 1 to n. So if I had data where, say that a1 happens to equal 1, a2 happens to equal 3, and say I went out to a4 or something, then it'd be equals to like 6 or something like that. What this is saying is add up all these numbers, whatever these a's are. This subscript I is the index. The index ends up as my subscript. And what's going to happen is I is going to increment until it gets to n. So this way it's written generically, but I could very easily simply write something like, what is the sum I equals 1 to 3 of I? Well, what that's saying is the first time through I equals 1, so this is 1, plus, sigma means add them up. Now I is going to increment, so now it's 2, so I is 2, 2, plus now I is going to increment, so now it's 3, it's 3, but I reached this limit up here. That's telling it where to stop. So it's saying add these up. So 1 plus 2 is 3, plus 3 is 6. So this is equal to 6. This sigma again, this means add up the values. Now, so let's just suppose I wanted to add say the first 100 integers. Now I could write that as 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 yada 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 all the way up to plus 100. Or I could simply say, using sigma notation, the sum I equals 1 to 100 of I. Done. This says the exact same thing as all of that. This notation is very compact. Now there's a few results from using sigma notation that are very useful. There's some summation formulas that you really just need to simply keep in your back pocket. You need to simply remember these. Now, the sum I equals 1 to n of c, where c is some real number, so let's put up here c is an element of the real numbers, equals c times n. And the reason being is, let's just suppose that this is the sum I equals 1 to, say, 10 of 5. Well, what that is 5 plus 5 plus 5. So this is a constant. I doesn't affect it. I just keep going through this 10 times, adding up whatever's in here every time, on out to 5. So I'm going to have 10 of these 5s. Well, that's the same as 10 times 5, which is 50, which is exactly what this is saying. Now, the sum I equals 1 to n of the I, this same way of adding up the first n integers, there's a nice formula for it, and it equals n times n plus 1 over 2. So this is checking out something real small. Let's say I want to take a look at the sum I equals 1 to 3 of I. That's 1 plus 2 plus 3, which we already said was 6. But according to this, see, n is 3, so this would be 3 times 3 plus 1 divided by 2. This is 4 times 3 divided by 2, which is 12 over 2, which is 6. Now, obviously, if I'm going to add up the first 3 numbers, I'm just going to add them up. I'm not going to use this. But what about that situation where we're going to add up the first 100? So the sum I equals 1 to 100 of I equals 100 times 100 plus 1 divided by 2. That equals 100 times 101 divided by 2, which is 10100 divided by 2, which is 5,050. This is a lot faster than going 1 plus 2 plus 3 plus 4 and so forth. Now these other two formulas is the exact same idea, only rather than adding up the first I integers, the first I integers squared and the first I integers cubed. So as an example, this one, if I wanted to sum I equals 1 to, let's just do 3, of I squared, that's 1 plus 2 squared plus 3 squared. Of course, 1 squared is 1, so I didn't bother with it. This last one is cubed, so if I want to sum I equals 1 to n of I cubed, that's 1 cubed plus 2 cubed, cubed plus 3 cubed. And rather than actually cubing these and working it out, here we go. There's some nice formulas that you can input with a value of n, and bingo, you can calculate it very, very quickly. These are very, very nice results, and you're going to need them when we start calculating some Riemann sums. So just stick these in your back pocket and have them handy, because like I said, you will need them.